Okay, hello everyone. I'm so glad to be here to be part of the educational course Global Open Science Electrophysiology. And today I'll introduce the Chinese interface, the WeBrain platform to GBC. Just as Professor Aaron said in the morning, WeBrain is an important part of GBC, and it's handling for the big EEG data, and it's a companion piece of CBrain. Today, I'll talk about how to use EEG pipelines on WeBrain platform, and hoping you can understand what WeBrain can do and how to operate it. WeBrain, just like CBrain, is a web-based computing platform, and it enables large-scale EEG and EEG fMRI multimodal data storing, exploring, and analyzing using cloud high-performance computing. It provides a wide computing resource, so it significantly reduces the technical expertise required to use these resources. And the core advantage of the platform is its accessibility. So it's not necessary to install any software or system for users. All you need is a modern web browser of any kind. It is a website of WeBrain. You can log in, use the URL or the QR code. In one of our papers published in 2021, we introduced the WeBrain architecture. Based on the web, 3 basic services are provided for users. That is the data service, the tool service, and the resource service. Technically speaking, WeBrain integrates the computing resources, the computing technique, such as the distributed computing, the database, the Docker technique with the complex EEG data analysis. So this integration can standardize the processing of complex EEG analysis and promote the scientific research specifications. To access the WeBrain, the user needs an account first. If you don't have an account yet, you should register first. After logging in the WeBrain portal, you'll see the user-friendly interface. It's very simple. There are 4 main modulars. My monitor, which monitoring the workflow of your processing of EEG data. And my project, here you can create the new task and use the EEG pipelines. And my file, here you can upload or download the file, the data, and download the results you proceed. And my statistic, which represents the completed workflow. Here is my file modular. Here you can manage your data and the results. You can first upload a data set by the new file. It is noted here, data should be compressed as a zip file first. And then you can view or edit the file or check the results. After processing of the data, you can download the results as one zip file, and the download link is sent to the mailbox. In my project, here each project on WeBrain can utilize a variety of EEG processing tools. Researchers can select the appropriate tools and files necessary for their project. Here is the steps to create a new project by new task. Step 1 is adding the task, filling the name or some descriptions. Step 2 is to choose the tools and the EEG pipelines you want to use. Step 3 is choose the file you want to proceed. Also, you can view or edit the task here. WeBrain integrates a comprehensive suite of EEG tools from the renowned toolbox like EEG Lab, the Field Trip, SPM, as well as the WeBrain platform. The tools in WeBrain include such as the REST, the Reference Electrode Standardization Technique, bed block marking, IC running, quality assessment, pre-processing of continuous EEG raw data, the power spectrum analysis, the event-related potential analysis, and the EEG network calculation, network topography analysis, generation of real head conduction model, and EEG source imaging. WeBrain supports a wide range of EEG data formats. It covers almost all the EEG data formats of the EEG acquisition systems in the market, such as the SET, the data format, the CDT, the CNT or BDF, and so on. Okay, next, I'll show you some EEG pipelines available in WeBrain. The first is the pipeline of quality assessment of continuous EEG raw data. For the raw EEG data with artifacts such as the EOG artifact, the EMG, or the artifacts because of the head motion, here WeBrain provides multiple methods for detecting the quality of the data and rating the EEG raw data as such as A, B, C, D, the rating perfect, good, or poor, or bad. After high-pass filtering and segmentation of the data, the 4 methods are involved, including detecting the constant or non or if signals in each window, detecting the unusually high or low amplitude, detecting high or power frequency noise in each window, and detecting how correlation with other channel in each window. After the above steps, there a number of indices relative to the data quality are calculated, and the EEG raw data are rated. And here, the bed channel and the bed blocks can be marked, and these marked blocks are not proceed in the following analysis. The second is the reference electrode standardization technique. As we know, the reference electrode is critical ensure in EEG analysis. And there are many kinds of offline EEG reference techniques, such as the average reference, the vertex reference, the linked mastoid reference, or the single, the left or the right mastoid reference. But because there is no one neutral point on our surface body, so these currently used reference may introduce undesigned biases for the EEG data. So REST used the mathematical method and aims at building the currently used reference and the theoretical zero reference. So a point at infinity, which is far from all the possible neural sources, is used as the approximate zero of potential and is realized by REST. So what is the advantage of REST? Here are two examples. First is in the application, the clinical EEG recording. In clinical EEG, according the non-unipolar reference are commonly used, such as the contralateral ear reference or the ipsilateral ear reference. But the currently used offline reference, such as the average reference or the linked mastered reference, based on the subtraction, can't give a valid reference method. So the forward comparative analysis may be blocked because due to the lack of the uniform re-reference method. But REST can solve this problem. That is, REST can transform the non-unipolar reference to the unipolar reference. The second example is the bad channels. We often encounter the problem, the EEG data with bad channels because of the electrode problem, the recording process, or the equipment problem. And we always adopt the interpolation method, such as the spherical spline interpolation or the neighborhood interpolation. But in our simulation, we found the interpolation using reference electrode standardization technique can quickly and effectively reconstruct the signals or bad channels, accompanied by re-referencing to an ideal infinity reference. So we combine the above the quality assessment and the REST technique into the EEG pre-processing. So for the raw EEG data with artifacts, quality assessment of EEG raw data is performed automatically. And after the passband and notch filtering, the artifact removal method based on the EOG regression and the ICE-based methods are performed here. Then REST here is used for the bad channel interpolation and re-referencing. After that, quality assessment of pre-processed EEG data is performed again, and the residual bad blocks are marked. Then the clean EEG data with REST reference are obtained finally. This is the pipeline of EEG pre-processing. It can be done automatically. The pipeline of EEG source imaging provides a tool to obtain the source signals of EEG or ERP data. After loading the EEG data and check the data, the channel location, and the sampling rate, The lead field matrix is calculated by solving the forward problem based on selected head model and channel locations. And after the passband filtering and epoch extraction, EEG data is subjected to estimated the sources to obtain the EEG signals in the source space using the inverse methods, such as accelerator here. And if we want the source signals or brain regions, we can match the source signals to a brain template, such as the AEL template. After these steps, the EEG source signals in the source space or the brain regions can be saved as a result. For the pre-processed data, all the source data we obtained, we can also do some other analysis in WeBrain. Here is showing the EEG network construction pipeline. WeBrain includes 4 EEG network construction methods, including the correlation, the coherence, PSI, and PLV to obtain the EEG network, both at the skip electrode level and the source level. As a complement of WeBrain, we also have an offline version named EEG pipe. It can be done from the WeBrain website. EEG pipe is compiled using the MATLAB runtime, the software. So if you use the offline version, you should install the MATLAB runtime first. EEG pipe have the same tools, the EEG pipelines with the WeBrain, have all the tools here. You can use the offline version and go forward to the other analysis and the results visualization. Okay, WeBrain is sponsored and driven by the China, Canada, Cuba International Brain Corporation project, that is the CCC Axis project. And thanks to the project and to other members in the WeBrain team here. And in the next few minutes, I invite you to watch the demo video and see how to operate the WeBrain. If you have a laptop, you can open the browser and log in the WeBrain website here using address.
WeBrain is a web-based big data management and computing cloud platform developed by the University of Electronic Science and Technology of China, enables EEG and multimodal data storing, exploring and analysis standardizing. Users can log in and use the cloud platform through a web browser, without any programming, software, or system installation requirements. In this video, we will briefly show you how WeBrain works. First, you can enter WeBrain homepage through the website. You can also download sample data from the homepage at Resources, and the WeBrain manual and tool instruction at Documents. Click the Visit WeBrain Portal, you will go to Login page. If you don't have a WeBrain account, please register first. Fill registration information and submit. After submitting the registration, please check your email and click the email verification link. When your registration request has been approved by WeBrain administrators, your account will be fully active. Then we can use the username and password to log in. Log into WeBrain. The main screen of WeBrain is displayed. There are 4 modules of WeBrain. My monitor can monitor the current task processing status. My project lists all the tasks that are running and have completed. My file shows the original data we uploaded and the newly generated result data. My statistic displays the completed typical data workflow in WeBrain. You can also use the account settings to change your profile and password. Now, we'll get into a demo of the WeBrain pipelines. First, we upload the data files that need to be processed. It should be noted here that the uploading file needs to be in the form of a compressed file, which contains multiple files or multiple zip files of subjects. Please refer to the WeBrain user manual for specific file format requirements. Then, upload the new data through New File, input the name, the optional label and description of the data, and then click Select File and Start Uploading to complete the uploading of the data. After successful upload, we can see the uploaded data in my file. Next, in my project, we have access to a variety of EEG processing pipelines. Click on New Task to create a new EEG processing task, which consists of 3 steps. The first step is filling the task name and description. The second step is to select tools you want to use. Here you can see all the EEG processing tools in WeBrain, including EEG Quality Assessment, EEG Preprocessing, EEG Reference Electrode Standardization Technique, Power Spectrum Analysis, Event-Related Potential Analysis, Network Calculation, EEG Source Imaging, etc. Here, we choose EEG Preprocessing as an example. Click and select WB_EG_PrePro, version 1.0, to enter the parameter setting page. Place the mouse on blue words Parameter Description. Descriptions of tools and parameters will be displayed. The parameters in the preprocessing process include bad channel interpolation, bad window removal, channel selection, ICA artifact removal, filter band selection, alternating current frequency setting, etc. You can set the parameters according to the data and requirements. Here, we proceed to the next step with the default parameters. After tool selection and parameter setting, proceed to step 3 to choose file. Select the data file we want to work with. Click on Execute and check on OK. The task will be in the list of tasks. At this time, we can enter my project to check the status of the data. If the data is being processed, the status is waiting or executing. If the data processing has been completed, the status will display Succeed. For these tasks, you can view the data processing logs by clicking on Detail. Click on plus to show files in the result folder. Scroll down to see log information. Click on Zip and Download to download results. Then, the download link will be sent to your email. Alternatively, we can go back to my file on the main page to view and download the results. With the pre-processed data, we can do a variety of EEG post-processing. Here, we create a new task to calculate the EEG network. During the tool selection and parameter setting, you need to pay attention to the selected frequency band, epoch length, label, the channel selection. Here are 4 ways to calculate brain networks: the Pearson's correlation, magnitude squared coherence, phase synchronization index, as well as the phase locking value. For the resting state EEG, the default parameters can be used for processing. Select the data to execute. and WeBrain starts the automatic processing. Similarly, the calculated network results can be downloaded through My Project or My File. Then you can move on to the next step of metrics calculation, visualization, etc.
Okay, that's the processing in the WeBrain. Is there any questions? There are a few minutes, okay, 5 minutes. Maybe you can register and have a practice. Okay. Thank you.